So this is going to be the trig review, so Chapter 8, Part 2 test. So we're going to be talking about 30, 60, 90 triangles, 45, 45, 90 triangles, a squared plus b squared equals c squared, and SOHCAHTOA. So we can look at this and we see that 60-degree angle, so we know that it could be a 30, 60, 90. So my 30, 60, 90 triangle, the side that sits across from 60 degrees is x square root 3, across from the right angle is 2x, and across from what's left, so that 30-degree angle, is going to be x. So my numbers on this side, so what we can do is if x represents that side and 5 also represents that side, it means they should be the same. So x equals 5. So now I just plug my x value in, so this is 5 square root 3, and this is 2 times 5, which gets me 10. Okay, so another 30, 60, 90. So my equation across from my right angle is 2x. Equation across from 60 is x square root 3. Across from 30 is going to be x. So I can set these equations equal to each other. So So I'm going to get 2x equals 26, divide by 2. So x equals 13. So now I just plug that in. So this side represents x. And this side represents 13 square root 3, because you take out the x and just put that 13 in. Okay, following the following ratio, so sine of A, so let's just do all the ones that go from angle A first, so these three. So from angle A, this is my hypotenuse, my side opposite of it, and my side adjacent to it. So if I write SOHCAHTOA up here, okay, so sine is my opposite, so R, over my hypotenuse, so T. Cosine is adjacent, so S, over my hypotenuse, which is T. My tangent is opposite, so R, over my adjacent, S. So we're just trying to create the fractions based on my adjacent, opposite, and hypotenuse in SOHCAHTOA. So now I'm going to erase this so we can do it coming from angle B. So my hypotenuse should stay the same. So this time we're coming from B, so this is my adjacent, the side opposite of it. Okay, so sine, let's circle my B ones here. So sine of B is my opposite, so S, over my hypotenuse, T. My cosine is adjacent, so R, over my hypotenuse, T. Tangent is my opposite, so S, and my adjacent R. Okay, this one is not 45, 45, 90. It's not 30, 60, 90, so we're going to have to use our SOHCAHTOA and probably use our calculator to be able to do this. So right now I am coming from this 48 degrees. So this is my adjacent, this is my opposite, and this is my hypotenuse. So right now the two things I have information on are my adjacent and my opposite. So I need to look for, out of my sine, cosine, and tangent, the one that talks about adjacent, so A and O for opposite. So tangent is what we're going to use. So I'm going to get tangent of my degrees, so 48 degrees equals my opposite, so X, over my adjacent 5. Multiply both sides by 5, so 5 tangent of 48 degrees should equal X, so we're going to type that into our calculator. So X is going to equal 5.5531. Okay, so this time we're trying to find this X here, so if I label my sides, this is going to be my opposite, my hypotenuse, and my adjacent. So if I go SOHCAHTOA, I have information on my adjacent and opposite, so we're going to use tangent because we need O and A. So tangent of my angle, so X, is equal to my opposite, 47, over my adjacent, 25. Okay, X is sitting inside tangent this time. I can't just divide by tangent to get rid of it because that X is sitting inside of it. So to get rid of tangent, we can do the inverse tangent. So whenever you're trying to solve for that angle, you're probably going to do the inverse to cancel this out. So X equals the inverse of tangent of 47 over 25. So I'm going to type in the calculator with that little inverse sign. 47 divided by 25. So my x is going to equal 61.9908 degrees because I'm trying to find an angle, so label it with degrees. Okay, this time it looks like we're coming from this 70. Okay, so my side adjacent, opposite, hypotenuse. So this time I have my hypotenuse and opposite. So I need to find O and H, so we're going to use sine. So sine of 70 is equal to my opposite, so 50 over my hypotenuse x. This is when we're going to have to move this x around. So you're going to multiply both sides by x. So now we have x sine of 70 equals 50. Divide by sine of 70. Okay, so x equals 50 divided by sine of 70. So when I type that in my calculator, 50 divided by sine of 70, my x is going to equal 53.2089, and then we are going to label it feet. Generally, if there's a picture or a story problem, you're going to label it feet or yards or meters or inches or something like that, okay? So make sure you label. All right, this one, we got a 45-degree angle, so we can think it's a 45, 45, 90. So my equation that always sits across from my right angle is we're going to use x's. So x squared of 2, and then my two other sides are x's. So right now, if I set these equal, my x represents 5 square root of 2. So I need to plug this in for x to find this side. So I'm going to have 5 square root of 2 times the square root of 2. Well, 2 times 2 is 4. So now I have 5 square root of 4. The square root of 4 is 2. 5 times 2 is now 10. So 10 is that side. Okay, we're coming from this angle here. So I have my adjacent side, my opposite side, and my hypotenuse. So SOHCAHTOA. I need the side that includes my adjacent and my hypotenuse, so it looks like we're going to use cosine. So cosine of x is equal to my adjacent 9 over my hypotenuse 20. That x is sitting inside cosine. Whenever we're solving for an angle, we have to use an inverse to get that x by itself. So we're going to say cosine, inverse cosine of both sides to get rid of that cosine. So x is equal to the inverse cosine of 9 divided by 20. So I'm going to type in inverse cosine of 9 divided by 20. So whenever you're solving for x, you're most likely going to be using an inverse to get that x by itself like that. So x equals 63.2563, and we're looking for an angle measure, so we're going to label it degrees. Okay, it's not a 30, 60, 90, it's not a 45, 45, 90, and there's no like 23 degrees or something like that inside it. So I'm just going to go back to my generic equation of a squared plus b squared equals c squared. So I'm going to label my sides. My c should always sit across from my right angle, and then I'm going to label my other ones a and b. So a squared plus 13 squared equals 14 squared. 13 squared is 169. 14 squared is 196. We subtract. So a squared equals 27. The opposite of squaring is square rooting. So a equals the square root of 27. I need to break this down into simplest radical form, so we're going to do radical jail. So we have the square root of 9 and the square root of 3. I'm trying to make that a 9. This breaks to 3 and 3. So if I put them all in my radical jail, I have 3 times 3 times 3. You select your pairs. One escapes jail, one dies. So now I have that 3 that escaped, and then this 3 that's left. Okay, so my a, or my x in this situation, is going to be 3 square root 3. Okay, describe each angle. So this is going to be angles of elevation and depression. Okay, so this is going to be my E, and this is going to be my D. Okay, so here's my horizontal line of eyesight. To make this angle 5, you're looking downward, so it's depression. My next one, for angle 6, here's my horizontal line. We are looking upward to make that angle 6, so it is elevation. Angle 7, here's my horizontal line. To make angle 7, you're looking downward, so it is depression. and then angle 8 down here. Here's my horizontal line. To make angle 8, you are looking upward, so it is elevation. Okay, I have this kite. So let's go ahead and label what it tells me. It says LHI is 20 degrees. So right here, it is 20 degrees. Okay, in kites, remember that those two angles should be the same. So this is also 20 degrees if we wanted to say that. Okay, so we have that 20-degree angle, and it always creates perpendicular lines in kites. So all of those will be perpendicular lines, so create 90-degree angles. So I also have HI representing 10. Find LI and KL. So right now, if you look at this triangle here, this represents 20 degrees, this represents 10, and we have our right angle. Okay, and I need to find, let's see, one of them is LI, so I need to find this length. So this one right here. So we're going to say it's X. So if I'm coming from that 20-degree angle, this is my hypotenuse, this is opposite, and this is adjacent. So if I'm doing SOHCAHTOA, I need the one that includes opposite and hypotenuse, so O and H. So I'm going to do the sine of 20 is equal to my opposite over my hypotenuse. Multiply both sides by 10. So 10 times the sine of 20, X is going to equal 3.4202. Okay, so that means LI is this 3.4202 equals that. Okay, and then I also want to know KL. Well, these should be congruent if they're being bisected, because this angle 20 is the same because it's an angle bisector, and it will create that right angle. Plus, these two lengths are the same. So this should also be 10, so it'll be the exact same triangle. So KL should give you the exact same length there.